solve another Leetcode problem. 1690, still Game 7. Alice and Bob take turns playing this game, and also Alice is gonna start first. So there are n steals, so this gonna be n steals arranged in a row. So on each player's turn, they can remove either the leftmost or the rightmost side. So let's try to understand it like this. So we have an array of 5, 3, and 1, 4, 2, and Alice is gonna start first. So for each of the turn, Alice is gonna remove maybe left side or right side. So if Alice remove from the left side, so Alice will collect a score after removing this one. So this value gonna be the score collected by Alice. And for the next turn, maybe Bob wants to remove steal from this side. So 3 plus 1 plus 4, and this value gonna be collected by Bob. And we want to return the maximum difference of the all scores collected by Alice minus all scores collected by Bob. Yeah, so according to this kind of a return, and we're gonna define a DFS plus memorization, similarly dynamic programming, to solve the problems. Yeah, so for our DFS, we're gonna include the boundary, so from L to R. Yeah, but the return for the DFS is gonna be our maximum result. Yeah, it's gonna be the maximum difference of the score of Alice minus the score of Bob. Yeah, actually, the score of Alice minus the score of Bob. So what is the score of Alice? So Alice's score, for example, it is this areas, because after removing this one, Alice will collect the score of these areas. It means the sum of these areas. And so what about the Bob's score? Bob's score is these areas. Yeah, so in our DFS function, so for example, this is gonna be Alice, and then minus the DFS in these areas, this is gonna be the Bob, and we're gonna check the maximum result. Yeah, so this is just from one side, from the right side, or maybe it can also from the left side, after remove the left side, and what left behind is 1, 4, 2, and we're gonna use DFS to check them. Okay. Now let's try to write the formula to solve the problems. So we're gonna use a test, and I'm gonna define a DFS, and I'm gonna prepare two pointers. It's gonna be L and R. So I'm gonna call this function, and it's gonna be from 0 to length of steals minus 1. So the condition for the boundary check is that if this L equals to R, this means that there's only one steal left. So if there's only one steal left, no matter Alice do it or Bob do it, after remove this steal, definitely there's nothing inside the array. So there's nothing I can plus, so I'm gonna return a 0. So this is the boundary check. Now I'm gonna prepare a left and right. This left means after remove the steal from at the left edge. Yeah, if it is at the left edge, so for the so for the Alice, it's gonna be the sum of all the values of the steals. It's gonna be the L plus 1, because I removed a steal from the left side to R plus 1. And this is for Alice. And so the Alice score need to minus the score of the Bob. So it means definitely this value I'm gonna minus the value for the Bob. So for the first term. Yeah. So for the Bob, it's gonna be L plus 1 to R. And similarly for the right side, we just need to copy it and change it to the right side. So it's gonna be the sum of L to R. This means we moved from the right side. This is gonna be L to R minus 1. And our final return is gonna be the maximum of the two. Yeah, of the left side and the right side. So the function executes like this. From the beginning, we have a whole array. And then we're gonna choose to remove the right side or remove the left side. And then we're gonna sum up all the values, and we're gonna define these values as Alice. And then we're gonna minus the value for this DFS call. This DFS definitely it is the score currently for Bob can collect if he plays optimally, and this value minus the maximum value from the Bob, definitely it's going to be the final result. But this certainly removes the left side, and also it is possible to remove from the right side. If we remove from the right side, similarly, we're going to have the same formula, just remove the right side and minus the DFS. And for this DFS, definitely it will, let's just try to use maybe just two values, or maybe 3 values. Let's just use 5 and 3. Let's just use 2 values. So after remove this 5, we're gonna have a sum of them. It's gonna be 3, and then we're gonna minus this DFS. So this DFS is gonna be only left behind. It will be this number 3. It's gonna be 3 minus 0. So this is gonna be the left side if we choose to remove from the left side. And similarly, if we remove from the right side, it's going to be 5 minus 0. Definitely, we're going to choose the maximum of the 2. So it means the final result is 5 if Alice and Bob play optimally, because Bob definitely didn't remove anything. Alice just remove a steal and collect some value. But for Bob, just remove it and cannot collect because the array is empty. Yeah. And if this array, maybe it is longer, like 5, 4, and 3, definitely we're going to solve the sub problem. Yeah, and the sub problem will run recursively like this. Yeah, so this means, for example, if I remove a steal from the left side, definitely I got a 4 and 3. It's going to be 7 for the Alice. And if I remove from the right side, definitely I'm gonna remove this 3. It's gonna be 9 for the Alice. And then this 7 gonna minus a value for the Bob, and 9 gonna minus a value for the Bob. Let's try to check this 7. If there is 4 and 3, and what is the maximum value? Because this DFS, basically it is the maximum value. It's gonna be 4, right? Because 4 and 3, the maximum gonna be 4. And what about 4 and 5? So the maximum gonna be 5. Yeah, because this DFS definitely, as you can see, it returns the maximum value if there are only 2 numbers left behind. So 7 minus 4, it is 3. 9 minus 5, it is 4. Definitely we're gonna choose this 4 because 4 is bigger than 3. So this is the definition of the function. Yeah. So if we can do it like this, normally we can solve the problem. But let's just run it to check if it works. But currently, it's going to have time limit exceeded, and it is normal because we didn't optimize the sum of the steals. Yeah, currently the time complexity is n cubic. It is not okay. But we're going to define a function. I'm going to use a prefix sum. As you can see, it's going to time limit exceeded. So it's gonna be accumulate with the steals, and I gonna give an initial value to be 0. Now I just needed to change this one because this is R to L plus this is R to L plus 1. So it's gonna be pre R minus pre L. But as we have an initial value to be 0, it's gonna be pre R minus 1. It's gonna be pre R minus 1, R plus 1, I'm sorry, and minus pre L plus 1. Yeah. And similarly for here, this is gonna be pre R minus pre L. Now let's just try to check if we can pass. Yeah, let me submit it. Currently, it is not okay, because it has memory exceeded issues. So we have to prepare the memory part. So we're going to prepare a result. And normally for this problem, we can, because we use the cache, we can clear the cache. We're going to use the DFS with cache clear. We're going to clear the cache. After clear it, we're going to return this result. Yeah, this means for each of the function call, we're going to clear the cache. We're going to reduce the memory. Otherwise, it got a memory exceeded issues. Yeah, now let's try to submit it. Yeah, after clear the cache, as you can see, we passed, although it is 4 seconds, but it is okay. Now let's just analyze the memory. As you can see, there are gonna be memory exceeded issues because the memory is so big. It is more than 100 MB, and here if it exceeded, it didn't show anything. But definitely we're gonna remove the memory. Thank you for watching. See you next time.